What is mechanical energy? Mechanical energy is the sum of kinetic energy and potential energy. Now, kinetic energy is the energy of motion. So whenever an object is moving, so think of, let's say, a block sliding down the hill or a car moving forward. Anything that is in motion has kinetic energy. And kinetic energy, the formula for it is 1/2 mv squared. So as long as an object is moving, if it has some kind of speed to it, it has kinetic energy and therefore mechanical energy. Now, gravitational potential energy, that's mgh. So imagine if you have a ball above ground level. It has potential energy. It has stored energy. It has the ability to fall. And so it also has mechanical energy. So that's mechanical energy. It's the sum of kinetic and potential energy. So let's say we release this ball at rest, which means its initial speed is 0. Right now, the only thing this ball is going to have is potential energy. It doesn't have any kinetic energy because at this instant it's not moving. But it still has mechanical energy because it has potential energy. Now, when it falls, the height of the ball is going to decrease. And as the height decreases, the gravitational potential energy will decrease. But as it falls, it's gaining speed. And so its kinetic energy is going to increase. Now, as the potential energy goes down, the kinetic energy goes up. So what's happening here is that potential energy is being converted to kinetic energy, such that the mechanical energy remains constant. In this situation, the only force that's acting on this object is the force of gravity. And gravity is known as a conservative force. So whenever you have a system in which only conservative forces is acting on an object, the mechanical energy of that object is going to be constant. As this gravitational force acts on this object, what's happening is that the potential energy is being converted into the kinetic energy. So let's say if you lose 200 joules of potential energy, you're going to gain the same 200 joules of kinetic energy in this situation. So the total mechanical energy will be constant. So make sure you understand that. Anytime you have conservative forces acting on an object, the total mechanical energy of the system remains constant. Now, if you have non-conservative forces acting on an object, the mechanical energy will not be constant. It can increase or decrease. So let me give you an example. Let's say we have a block at rest and it's sitting across a frictionless surface, and we apply a force of 100 newtons. And let's say this block has a mass of 5 kilograms. And we're going to move this block for a distance of, let's say, 20 meters. Will the mechanical energy of the block, will it increase, decrease, or will it remain the same? Now, this applied force, it's not a conservative force like gravity or the elastic restoring force in a spring or the electric force. Those are conservative forces. An applied force is a non-conservative force, so this is going to affect the mechanical energy. Let's assume this block is initially at rest. Once we apply this force, the block is going to move, and so it's going to gain speed. Its velocity will increase, and therefore the kinetic energy is going to go up. Now, this block, it's not moving in a vertical position, so it's not going to gain any potential energy. We're not increasing the height of the block above the ground. We're moving it to the right. And so the potential energy is going to remain constant because the height is not changing. So because we're increasing the kinetic energy of the object while keeping the potential energy constant, this applied force is increasing the total mechanical energy of this block. In other words, this force is doing work on the block. And we can calculate the work done on the block by this force using this equation. So it's the applied force times the displacement. That's going to be 100 newtons times 20 meters, which is 2,000 joules. So because the block was at rest and we did 2,000 joules of work on it, this is going to be the total energy of the block. It's going to be equal to its mechanical energy, and at the same time, it's going to be equal to its kinetic energy. If we want to calculate the kinetic energy another way, here's what we can do. First, we could find the acceleration. The net force is 100 newtons because that's the only force acting in the horizontal direction. The mass is 5 kilograms. And if we take 100 divided by 5, that will give us the acceleration of 20 meters per second squared. Now, using this equation, we can calculate the final speed now that we know the displacement and the acceleration. The initial speed is 0, a is 20, and the displacement is 20 meters. "20 times 20 is 400 times 2, that's going to be 800. So taking the square root of that, the final speed of this block after this force has moved it 20 meters to the right is 20 square root 2, which if you round that's going to be 28.28. But the exact answer is 20 root 2 meters per second. Now we can calculate the kinetic energy of this block using this formula. So it's 1/2 mv squared. So 20 root 2, if you square that, that's going to give you 800. Half of 800 is 400. And if you multiply 400 by 5, that will give you 2,000 joules, which is the kinetic energy and also the mechanical energy of this block. Now let's work on some practice problems. A 10-kilogram ball is thrown downward at a speed of 14 meters per second from a cliff that is 700 meters above ground. What is the mechanical energy of the ball? So let's begin with a picture. Alright, so let's say that's the horizontal surface or the ground level, and the ball was thrown downward at a speed of 14 meters per second, and the height of the ball is 700 meters above ground level. Now, in order to calculate the mechanical energy, we need to calculate the kinetic energy and the potential energy. The kinetic energy is 1/2 mv squared. The gravitational potential energy is mgh. Now we have the mass of the ball, it's 10 kilograms. We know the speed, it's 14 meters per second. Gravitational acceleration is 9.8 meters per second squared, and the height of the ball is 700 meters above ground level. So first, let's calculate the kinetic energy. 14 squared is 196 times 10, which is 1960 times 1/2. So we have 980 joules of kinetic energy. And then 10 times 9.8 times 700 is 68,600 joules of potential energy. The majority of the mechanical energy of this object comes from its potential energy, as we could see here. Adding those two numbers gives us this result: 69,580 joules of total mechanical energy that this object possesses. So that's how you can calculate the mechanical energy of an object. All you need to do is find these two and add them up. Now let's look at this problem. An upward tension force of 500 newtons is used to lift a 15 kilogram block at rest on a horizontal surface for 5 seconds. So let's draw a picture. So here's the block, and we have a rope that we're going to use to pull up the block. So we're going to apply an upward force of 500 newtons. And the mass of this block is 15 kilograms. Now we're going to apply this force for 5 seconds. So the first part of the question asks, what is the upward acceleration of the block? So we need to draw a free body diagram. We have an upward force of 500 newtons, but we also have a downward weight force of, I'm just going to use W for weight force, which is mg. So that's going to be 15 kilograms times 9.8 meters per second squared. So we have a downward weight force of 147 newtons. Now the net force in the y direction is the sum of those forces. F is positive, W is going to be negative because it's going down. So we have an upward force of 500 newtons minus a downward force of 147 newtons. So the net force in the y direction is positive 353 newtons. So we can write that here. That's going to be the upward net force. So now that we know the net force in the y direction, we can calculate the acceleration in the y direction. So the acceleration is simply going to be the net force divided by the mass. So if we take 353 newtons and divide it by the mass of the block, which is 15 kilograms, that is going to give us the upward acceleration of the block, which is 23.53 meters per second squared. So that's the answer for part A. Now let's move on to part B. Calculate the vertical speed of the block at the end of 5 seconds. In order to calculate that, we could use this equation. V final is equal to V initial plus AT, but dealing with motion in the vertical direction. So the block is initially at rest on the horizontal surface, so V initial is 0. The acceleration is positive 23.53 because it's going up, multiplied by 5 seconds. So the vertical speed in the y direction is going to be 117.6 repeating meters per second. Now moving on to part C, we're going to calculate the height of the block above the ground. So to do that, we could use this formula. D is equal to V initial T plus 1/2 AT squared. So D is going to be the displacement in the vertical direction. V initial is 0. We have the acceleration, which is 23.53 repeating, multiplied by the time, which is 5 seconds, and we're going to square it. So the answer that I got is 294.17 meters. I'm just going to try that again, make sure my math is correct. So that's going to be the height above the ground. So I'm just going to rewrite that here. Now let's move on to part D. What is the total mechanical energy of the block? In order to find that, we need to calculate the kinetic and the potential energy. We now have the speed and we have the height of the object. So with those two things, we can calculate the total mechanical energy. So the mass of the block is 15 kilograms. The vertical speed is what we have here, 117.6 repeating, and we'll square that, plus the mass, which is 15, times g, which is 9.8, and then times the height, which is 294.17. All right, I'm gonna have to clear away some stuff here. So first, let's calculate the kinetic energy. 0.5 times 15 times 117.6 repeating. Don't forget to square it. This is going to be 103,840 joules, well, 40.8 joules. Now for the potential energy, it's going to be 15 times 9.8 times 294.17. So this is 43,242.99, but I'm going to round it to 43. So adding these two numbers, we'll get the total mechanical energy of 147,083.8 joules. So that is the total mechanical energy of the block 5 seconds later.